Hello students, we will start vectors, and vector is very important in other chapters. For example, a force and electric field, displacement, velocity, all are vector quantities, and so we can use any types of problems by using the vector algebra. So our topic is vector. So we will start the physical quantities. What is physical quantities? Those quantities which can measure by an instrument. It is called physical quantities. These are two types of physical quantities. Physical quantities. First one is scalar quantities, and second one is vector quantities. What is scalar quantities? Scalar quantities has only magnitude. But not direction. But vector quantities has magnitude as well as direction, and also follow the vector algebra. It is very important to describe a vector quantity. For example of scalar quantities is displacement, because displacement needs no direction. Distance needs no direction. Speed also needs no direction. Pressure. Vector, for example, displacement. Force, velocity, acceleration. These are vector quantities needs direction, and these are follow vector algebra. Now our chapter's name is vector, so we explain the vector in detail. The representation of vector. Suppose a vector A defined as the board ladder like this, or a arrow over it, an arrow placed over an magnitude, a letter like this. But the bold letter is difficult when written by hand, but a arrow placed over a letter, it is easy to write it. So we can use normally this. Now the magnitude of vector is defined as a vector of modulus. Modulus of a vector. This is magnitude of vector A. The property of vector. Properties of vector. First, it has a specific direction, of course. It has a specific direction. Second one is it obey parallelogram law of vector algebra. It obey parallelogram. We will discuss in further. Law of vector algebra. And third one is their addition is commutative. Their addition is commutative. Example, A vector plus B vector equal to B vector plus A vector. This is commutative law. Some examples we can take it. Examples. Suppose we can represent $50 meters in east-north direction. So a vector is represented as, we know this is east, west, north and south. So 50 meters in east, north, 20 degree. So 50 meters is the magnitude of vector, and the direction of this vector is 20 meter. This is an arrow represent the vector 50 meter, and the magnitude of the vector quantity represent the length of the vector, and the arrow represent the direction of the vector. Important notes. First, if a physical quantity has physical quantities has magnitude and direction but do not follow the vector algebra, so these quantities is not a vector quantities. So these quantities is not a vector quantities. For example, electric current, because current has magnitude and direction but it do not follow vector algebra. So sometime we can take it a scalar and sometime it is vector. Now, types of vectors. There are many types of vectors. First, polar vector. Polar vector. Those vectors which has starting points. Those vectors which has starting point. For example, displacement, force, velocity. Second one is axial vector. Those polar vectors which represent a rotational effect. Those polar vector which shows rotational effect and act along the axis of rotation. For example, torque, angular momentum, angular velocity, the third one is zero vector or null vector. Null vector and or zero vector whose magnitude is 0 and direction is indeterminate, whose magnitude is 0 and direction is not determinate. Example, if velocity is 0, so we can represent as 0 vector meter per second. The next one is unit vector. Vector of unit magnitude. A vector of unit magnitude and whose direction is same as that of the given vector. For example, a vector can represent is magnitude of the vector and the direction of the vector. So a vector is a cap is equal to a vector upon modulus of a. So this is the unit, this is the direction of a vector and this is the unit vector. Next, orthogonal vector. This is very important. Orthogonal vector. The three mutual perpendicular axes, those vectors having the direction of positive x, y, z axis, these vectors are represented as I cap in x direction, j cap in y direction and k cap in z direction. It is represented as this is x and this is y. So the orthogonal vector is k cap, I cap and j cap. Third, next one is like vectors. Vectors having same direction, and their magnitude may or may not be equal, like this. Next one is unlike vectors. Vectors having opposite direction, and magnitude may or may not be equal. For example, this A vector and B vector, or this and this, A vector and B vector. This is A vector, this is B vector, this is A vector and this is E vector. Next one is coplanar vector. Vectors lying in the same plane is called coplanar vector. Those vectors are lying in the same plane is called coplanar vector. Example, I vector, J vector are coplanar. J vector, K vector are coplanar. And K vector, I vector are coplanar. But I, J, K are not coplanar vector. Now, these are types of vector. Now, position and displacement vector. The next topic is position and displacement vector. What is position and displacement vector? Position is defined from a point with respect to a reference frame. For example, we have a reference frame X and Y, and this is the origin of reference frame. A particle of P is located at this point. It moves from P to P point, P dash point. So the position of P vector is defined from the origin, suppose R cap, and the position of P dash is defined from the, of course, origin R dash. So these are vectors, but the displacement of the P dash is from P to P. That is called delta R vector. So we can say that delta R vector equal to R dash vector minus R vector. For example, find position vector of a particle whose coordinates are 5, 7, 8. So the position vector R is defined as 5 I cap plus 7 j cap plus 8 k cap. These are position vectors and displacement vectors. Now some important fact about vectors. Important points. First, if a vector is displaced parallel to it, if vector is displaced parallel to it, it does not change. It does not change. A vector, and the parallel of this vector A vector is B vector, and the parallel of this vector C vector. So we can say that A vector equal to B vector equal to C vector. If a vector is rotated through an angle other than multiple of 2 pi, it changes. It changes. For example, if a vector A and it is rotated by angle theta, this is x and this is y, angle theta, and this is B vector. So A vector is not equal to B vector. Angle between two vectors. Angle between two vectors. The angle between two vectors are always the angle between two vectors are always taken by tail to tail. That is the smallest angle between two vectors. Suppose first vector is this A vector and other one is this B vector. So angle between A and B is represented by A and B. This is the angle between two vectors. For example, if a vector is this and a vector is this, A vector and B vector, so angle between it, A vector, B vector, angle between is this 180 degree. Now, the most important factors of the vector algebra is the mathematical operations on vector, and we will discuss in further lecture. Thank you so much.